All right, ladies and gentlemen, welcome back to another video with Mr. Kenton. And as I promised in the Intro to Redox video, I wanted to revisit the list of reactions that were there and wanted to show you how they would be represented as redox reactions, and also give you an opportunity to kind of see some practice with how you would assign oxidation numbers within a given reaction. So let me just dive right in here. So I've rewritten the three reactions that were on the PowerPoint slide. And, let's just take a look at the first one. So we've got iron metal, we've got sulfur, and then we've got it making iron 2 sulfide. And so as you're looking at that, the thing that I notice on the reactant side at least is I've got everything in its elemental state. And so if you think back to the rules that we talked about in terms of with assigning oxidation numbers, we said that if there was an element, that its oxidation number would be equal to 0. So for iron, because it's in its elemental form, it's going to have an oxidation state. I'm going to just write it up here above it as 0. All right. Now, the same thing is going to be true for sulfur, because sulfur is in its elemental form, S8. Keep in mind, you got your diatomics, Hofbrinkel or H-Brinkloff, but then you've got sulfur, which is S8, and phosphorus is P4. Those are the elemental forms of phosphorus and sulfur, respectively. So sulfur is in its elemental form, and so it would have an oxidation state of 0 as well. Okay. Now, as we begin to look at the product side, we've got iron 2 sulfide. Now, I know it's iron 2 sulfide because my charges have canceled. I know that sulfur has a -2 charge in chemical bonds and ionic bonds. So that means that if sulfur has a -2 charge, that means it's made up of an ion. Then that means the oxidation state of sulfide in this particular case is -2. Now, for the iron, I stated that it was iron 2 sulfide. That means that the charge of the iron here is 2+. So that means that the iron has a +2 oxidation state. Okay, so that would be the oxidation states for everything that's been listed in that particular process. Now, if we want to get very specific here, we want to think about what substance was oxidized. So if we think, remember, oxidation is loss. What substance lost electrons? That would be the iron. So we would say that FeS, so FeS is oxidized. And then our substance that's reduced would be the S8. Sulfur is our substance that got reduced, right? Because sulfur gained electrons. It went from an oxidation state of 0 to an oxidation state of -2. Okay, hopefully that makes sense. All right, if we look at the next one, we've got the reaction. We've got water vapor is decomposing into its component elements. We've got hydrogen gas and we've got oxygen gas. Now, I like dealing with my elements first because it's just easier that way. So I'm just going to focus on my product side. So I've got elemental hydrogen and I've got elemental oxygen. Now, both of those substances, because they're in their elemental form, they're going to have oxidation states of 0, respectively, right? Which leaves us with our water, right? And so if you remember, we talked about for nonmetals, there were some things we needed to consider. We said that oxygen was always -2, unless it was with a peroxide or fluorine. Well, we're not with a peroxide or fluorine, so we're safe to say that oxygen's oxidation state is -2. And then we got hydrogen. Now, we know this is a neutral compound, but we also need to consider, we said that when hydrogen was paired with when it was paired with a nonmetal, it would have a positive oxidation state of +1. Now, when you take a look at that as a compound, there's no net charge on water. There are 2 hydrogens, so each of them have a +1 oxidation state. When you add those oxidation states together, you got +2 and -2, so that adds up to 0. That gives us a neutral charge, right? So the oxidation states add up, they cancel out. That means that we've done this appropriately. Now, when we think about what's going on here, right, we want to think about, okay, what substance was oxidized and what substance was reduced? So which substance lost electrons? All right, now this is where it gets kind of tricky, right? So in a sense, H2O is what was oxidized and H2O is what was reduced. Now, specifically, it's the oxygen within water that was oxidized. They went from -2 to 0. That means it lost 2 electrons. And then think about hydrogen. That was the substance that was reduced. It went from a +1 charge to having a 0 charge. So the hydrogen was the component that's there that was reduced. It gained electrons. Okay. Hopefully that makes sense. And again, if you guys have questions, please don't hesitate to ask or bring them to class or come to office hours. All right, our last one. This one's going to be a real doozy. It's going to be real fun, right? Because in this particular case, we've got a lot of substances that are here. And again, I always like to focus in on my elements first. And so that being the case, I'm going to look at my oxygen. My oxygen has an oxidation state of 0. Okay. And then I'm going to start dealing with everything else, right? Now I'm going to go over to the product side for a second because I see oxygen in compounds. And like we saw before, when oxygen's in compounds, unless it's with fluorine or peroxides, oxygen's -2. So I got -2, I got -2 here, all right? Now, next I'm going to move into my hydrogens because hydrogen's going to be pretty straightforward here. It's just like it was before. It's at +1, right? Now, next up is carbon dioxide. I've got my carbons here. So I've got 2 oxygens at -2. That's going to be -4. So that means carbon here is +4. Okay. Now, if we're looking at this, we already see what's been reduced. Hydrogen here in this particular compound is +1. And so, and again, it's the +1 because we're dealing with the fact that we've got hydrogen bonded to a nonmetal. And so then for carbon, we're going to see that it has a very different oxidation number. It's actually going to have a negative oxidation number in this particular case. And so let's see here. Just kind of thinking through this one. It's a little bit more challenging. Probably should have picked a simpler one. But we know that there's 8 positive charges. So we've got 10 unknown for the carbon plus 8 equals 0. So I've got 10x equals -8. And so that means that x equals -0.8. So each carbon has an oxidation number of 0.8. Now, it is important for me to mention you can have these fractional oxidation states. It's not very common, but it is possible. And so we see that it goes from -0.8 to +4. So that means that carbon lost electrons and oxygen is the substance that gained them. So we think about what's being oxidized here. Oh, oops, that might really wrong. So the substance that's oxidized, C10H8, and our substance that was reduced is oxygen, right? Now, I hope that's been helpful. Hopefully that was useful to you guys. Feel free, if that was too fast, watch it again, slow it down, do what you need to. Feel free to bring questions, because I'll be more than happy to help. So thank you guys for tuning into this. Hopefully it was helpful, and I'll see you guys again soon.